So systems of inequalities, in this case we're given two. We need to graph each one of them, decide which way to shade, and then we're going to shade where everything is true, right? Okay, so if we're given this first equation right up here, how should we figure out the table for that? Okay, some people want to put it in the calculator. Why don't you go ahead and put it in the calculator? Negative 2 squared is 4. 4 minus 2 is 2. 2 minus 6 is negative 4. Negative 1 minus 1 is 0, so that's a negative 6. 0, 0, that's a negative 6. 1 minus 6 is negative 4. 4 plus 2 is 6, minus 6 is 0. Okay, so I'm already done, and you're just now getting the calculator turned on. So I'm not being rude. I'm just trying to make a point. Sometimes it's faster. Just do it in your head, right? Okay, sometimes it's faster to plug it in the calculator and get a table that you're confident of. Okay, but sometimes it is faster to just do the stuff in your head. All right, that's the only point I was trying to make. Let's go ahead and plot these points on the graph. Negative 4, positive 6. Negative 3, 0. Negative 2, negative 4. Negative 1, negative 6. 0, negative 6. 1, negative 4. And 2, 0. So what shape is this? Parabola. So what can I not see on this parabola? I can't see the vertex, can I? I know it's in between those 2 points. I just don't want you to think it comes down here and goes straight across and then goes back up. Fair enough? And we've talked about just a second ago the fact that with inequalities we do have to decide whether we're drawing a solid line or a dotted line, correct? We know this is a solid line because it's greater than or equal to. Whenever that equals to is there, we do know we have a solid line. Okay? So there's my parabola. I'm sure you'll draw a better one. There. That makes me feel a little better. Okay? Now, am I going to shade inside of this parabola or outside of this parabola? Do you remember how to decide? Choose a point. Like 0, 0. Yeah, that's the easiest one, isn't it? Okay? If I plug in a 0 for my x and a 0 for my y's, I get 0 is greater than or equal to negative 6. Is 0 greater than or equal to negative 6? It's yes, right? It's yes, it is greater than or equal to negative 6. So if I was going to shade, I would shade toward the point, right? I would shade inside of the parabola. Does that make sense? Okay, good. Now, let's graph the other shape. Anybody tell me before we start what the other shape is? A line. How do you know that? Because, okay, that's a good reason. It's in the form of slope-intercept form, right? Y equals mx plus b, all right? That's not the only way we can know, but I'll accept that reasoning, okay? Do you think this is going to be faster in the calculator or not? No. Negative 1 plus 3. 0 plus 3. 1 plus 3. 2 plus 3. 3 plus 3. That was pretty easy, wasn't it? Okay? So negative 3, 0. Negative 2, 1, negative 1, 2, 0, 3, 1, 4, 2, 5, and 3, 6. Once again, this is going to be a solid line like we talked about earlier because it's greater than or equal to, or in this case, less than or equal to, right? Okay, so am I going to shade above this line or below this line? How do you know so quickly that it's below? Because it's less than, right? Less than or equal to, we know is below the line. So what part of this should I shade? Just this part right here, right? How many solutions do we have? A ton, right? I want you to give me at least 3 points that are in the shaded area. 0, 0 is clearly in the shaded area, right? It's right here, 0, 0. Somebody said something else. What'd you say? -1, 0? Okay. 1, 0. Wow, we're getting really creative today. Okay? Creative or not, they're still all in the solution, aren't they? So now I need to throw a monkey wrench in. What about -3, 0? Right there? That's in the solution? Does it matter that's in an intersection? No. It's going to be equal to both of them, but is it still part of my solution set? Yes. And the reason it is because why? Or equal to. Because of both of them are equal to, you can choose points on the line. So what about the point -1, 2? That one. It is, isn't it? That's part of the solution because it's on this line, and this line is less than or equal to. So that means it can be part of the solution set. Fair enough? Please look at number 3. Can you please tell me what shape the first thing is? Oh, time out, time out. Time out. Look back at 1. I forgot to show you something real quick. I want to graph. Maybe I want to graph. Okay. Tab. I want to graph x squared plus x minus 6. But watch. I want to actually graph greater than or equal to. And then I want to graph less than or equal to x plus 3. So why do these not look the same? Oh, my windows. What kind of window do I need? Don't I need a standard window? I don't have to go put every time the numbers in on my settings. I just need a standard window in this case. Do these look the same? Now they shade everywhere for both ones. We only shade where everything is true, right? But notice that this part in here is darker, so we know that that's the true solution. Okay? So can you do these in your calculator? Absolutely. But if I give you a table, I expect you to fill it out, and I expect you to plot those points on the graph. Fair enough? Okay, so now look at number 3. Sorry about that. So I'm asking, what shape is this one right here? Rational. How do you know it's rational? It's a fraction with x in the denominator. Very good. Okay, so given the values that we are, let's figure out the y values. When x is 1, y is 8. When x is 2, y is 4. That's okay. When x is 4, y is 2. When x is 5, 1.7? Where? It does? Okay, well, we'll go with that. I'm okay with that. What about when x is 8? So when x is 1, y is 8. When x is 2, y is 4. When x is 4, y is 2. When x is 5, y is 1.6. Not 1.7. When X is 8, y is 1. Okay, so far? All we did is graph the points that we have, right? Okay, what about the next one? How do I graph that one? What shape is that going to be? A line. How do you know that? Because you've been doing for 8 years now? Maybe? Okay. Maybe 7. So when x is 1, what is y? 8. When x is 2, what is y? 3, 4, and 5, 0. So let's plot these. 1, 8, 2, 6, 3, 4, 4, 2, and 5, 0. What the heck did I do? Oh, I'm good. Solid or dotted? Because it's less than or equal, remember it is solid. Okay? So the first one that we did, we drew it and then decided where to shade, and then drew the next one and decided where to shade. So this one, we've drawn 2 and not decided anything. Is that okay? Yes? So we did this on purpose? Yes, I just want to make sure you understand it's not required to decide where to shade yet. Okay? But look, we still have 2 more to graph, don't we? How do you graph the line y equals 0? What line crosses the y-axis at 0? The x-axis, right? So this is actually one of my stipulations, one of my constraints. And what about this one? What line crosses the x-axis at 0? The y-axis. So now both of these say greater than. So I know for this one I'm going to be shading to the right. And I know for this one I'm going to be shading above, right? So basically it has taken my answer and put it only in the first quadrant, hasn't it? Okay? So how do I decide between these two? What about this first one? That was our swoosh. Is that correct? Swoop, excuse me. That was our swoop. Okay? It's greater than our swoop. If we struggle, we can always choose a point. 0, 0. Oh, I can't this time though, can I? Because I'd be dividing by 0. Dun, dun, dun. So let's choose 1, 1. That's pretty simple, isn't it? If x is 1 and y is 1, 1 is greater than or equal to 8. No. So obviously I have to shade above my curve. My swoop, excuse me. Okay? What about my line? Where am I shading for my line? It's less than or equal, so it is below. So where's the only place on this whole graph where all 4 of these equations, or inequalities, excuse me, work? The little eyeball? How many eyeballs do you know that are shaped like that? Okay, we'll go with your answer. Okay? So tell me at least 3 points that are in that shaded area or part of the solution. 2, 5. 2, 5 definitely works. 3, 4. Oh, 3, 4 is on the line. Is that still okay? Yes. 1, 8. Ooh, that's on both of them, isn't it? Still works though, doesn't it? Okay. So before you come to class tomorrow, I need you to have done number 4 and number 2. Okay? Before we leave, though, I do want to show you home, new document. No, I want it to be a graph. Y equals 8 over x. And it's not equal so much as it is greater than or equal, so that's number 5. Hey guys, look at this real fast. When we graph this, Only this showed up. Did we do something wrong? All I did was put that equation into my y equals. Does it matter that this part didn't show up? It wasn't in our table, so it didn't graph. But in the end of the day, because of these two constraints, the y is greater than 0 and x is greater than 0, that part didn't matter anyway, did it? Okay? So the next one was negative 2x plus 10, but that wasn't equal. That was less than or equal. So really the only, that's showing you right now, we know it has to be in first quadrant because of these two constraints. So that is showing us that does work. Okay? Do you have any questions? Guys, I know you can do every single bit of this in your calculator, and if you need to, that's fine with, Control T to get to the table. Oh, but I can't do that when I already put my inequality signs on my, like here. If that already says less than or greater than, it won't give us a table. It won't give us table values. So if you want to get the table values from the calculator, you'll have to leave those as equal signs. Fair enough? Okay. But please, even if you are going to get the table values from the calculator, please make sure that these points are plotted on here and don't just graph something that looks similar to what you have on the calculator. Fair enough? Any questions about this? Please ask me if you do. Have a good day. Kingston out.